We have now come to the final video on Surds, except something else comes up, and we are looking at a very interesting aspect of Surd, talking about Olympiad-level Surd manipulation. So we want to see some very top-level Surds that you find in Olympiads, mathematics Olympiads. So the overview will be looking at multi-layered expressions and pattern recognition. Okay, so some expressions look pretty out of this world, but if you can understand the patterns and all that, you may be able to find your way. So but in introduction, surd or radicals appear frequently in Olympiad algebra because they often hide algebraic structure. So many complicated radical expressions simplify dramatically once the correct pattern is recognized. This lesson focuses on two key ideas: manipulating multi-layered surd expressions and recognizing hidden algebraic patterns. The goal is to convert multiplicated radicals into simpler forms using algebraic identities. Okay, so let's go on and talk about surds now. Again, we try to remind ourselves that a surd is an irrational number expressed using a root. So, an irrational number is simply a number that cannot be expressed as the ratio of two integers. So examples include root 2. Try hard as you may, you cannot express root 2 as the ratio of two integers. And we proved it. The whole video, the last video, of about 20 minutes or so, was just to prove that root 2 is irrational. All right, and we're able to establish that clearly. 3 root 5 is also irrational. Root 7 plus 4 root 3 irrational. Surds appear frequently in Olympiad algebra because they can often be simplified using clever algebraic manipulation. So let's remind ourselves of the basic rules of surd. We have the product rule, which says root A root B is the same thing as root AB. So that tells us that the product of two surds is equal to the it's not a good way to say it. The product of two surds. I mean, when you multiply two sorts, you can multiply the numbers under the sorts, basically. Quotient rule, root A over root B is equal to root A over B, basically. So conjugate identity now. So for conjugacy, so you have A plus root B. The conjugate will be A minus root B. A minus root B conjugate is A plus root B. And when you expand all of that, you have A squared minus B. These identities form the foundation for manipulating more complex surd expressions. So first of all, you want to recognizing perfect square surds, right? So you have many Olympiad expressions involve radicals of the form square root of a plus 2 roots b. These often come from squaring a binomial containing square roots. So consider root x plus root y squared. And when you do that, we did that in these two videos before now. That's x plus y plus 2 roots xy. And you can then have square root of, so that means that you have square root of x plus y plus 2 roots xy equals root x plus root y, like that. So if you can identify that, so similarly, if you have for negative, you have root x minus root y all squared equals x plus y minus 2 root xy. That's root x plus y minus 2 root xy equals the absolute value of root x minus root y. Okay, I mean, this even helps now. So whatever x is, whether x is bigger or y is bigger, the absolute value takes care of that idea. So these identities are the key to simplifying nested radicals, and we're going to see them one by one. So this one looks like what we considered in the 21st video, simplifying square root of 5 root 6, 5 square root of 5 plus 2 root 6. So first you compare this with, of course, if you assume that this is equal to root x plus root y, and then if you square both sides, the roots will be gone on the right hand side. And on the left, the roots will be gone on the left hand side. On the right, you have x plus y plus 2 root x. And you can then compare, you have x plus y equals 5, the rational part, then root xy is 2 root xy is equal to 2 roots 6. So 2 cancels 2. So you have root xy equals root 6. Square both sides, you have xy equals 6. So you can then solve the system. You can do the hardcore solving, or you can just think about the fact that you need two numbers to add to get 5 and multiply to get 6. And easily, this will be 2 and 3. So solve the system. Numbers satisfying this condition will just be x equals 2 and y equals 3. So you can then rewrite the expression as 5 plus 2 root x equals 2 plus 3 plus 2 root 6. So that means that the square root of 5 plus 2 root 6 is root 2 plus root 3, basically. Then for multi-layer, so still talking about multi-layered sorts now. A nested sort contains a radical inside another radical. So that's 3, for instance, 2 plus 2 root 2 and root 7 root 3 plus 2 root 2 here, and root 7 plus 4 root 3. The strategy is to rewrite the expression in the form root x plus root y all squared. Okay. So take an example 2 now. We have root 3 plus 2 root 2. If you assume that this is equal to root x plus y. Okay, well, I mean, since this is a separate video, you may not have seen the previous video. Let me just take the pain to do this and then show that the final answer is 1 plus root 2. It's pretty easy to do. So root 3 plus 2 root 2 is what we are considering now. Root 3, square roots of 3 plus 2 root 2. So want to simplify this, to simplify this. So we say let root 3 plus 2 root 2 be equal to root x plus root y. If you add a negative sign here, to be minus here too. So then square both sides. So you square both sides. So if you square both sides, you have square root of 3 plus 2 root 2 all squared equals root x plus root y all squared. So 2 cancels root. So you have 3 plus 2 root 2 equals, when you expand this, that'll be, of course, if you use that style, root x squared plus 2 root x root y plus root y all squared. So that means we have 3 plus 2 root 2 equals root x squared, 2 cancels root, power cancels root. So you have x plus 2 root xy. We already know root x plus root multiplied by root y is root xy together plus y here. So then we can collect the rational and irrational parts. For the rational part, you have 3 plus 2 root 2 now, the rational part. So on the right hand side, we have x plus y as rational, and the irrational 2 root x y. Okay. So from here now, so we can comparing terms now. We have comparing terms. We have x plus y equals 3, and we have, so we keep this, and then we have 2 root 2 equals 2 root xy. So 2 cancels, and when you divide through, so you have root 2 equals root xy. So if you square both sides, you have xy equals 2. We also look at this. So we need two numbers. When added, you get 3. So you have x plus y equals 3. But when multiplied, you get 2. So the numbers that satisfy this are simply x equals 2 and y equals 1, or x equals 1 and y equals 2. Anyhow you want to do that, so these are the two numbers that satisfy this. So 2 plus 1 3, 2 times 1 2. Okay, so you can then go back and say that root 3 plus 2 root 2, root 3 plus 2 root 2 is equal to root x plus root y, right? Root x plus root y, that was the assumption. So root x plus root y. So we have root x plus root y, and that'll be root 2 plus root 1. Or if you solve it rigorously, you are going to get x is 2, y is 1, or x is 1, y is 2. So same thing at the end of the day. So you have root 2 now plus 1. That means you have 1 plus root 2. So you can conclude, so square root of 3 plus 2 root 2 is equal to 1 plus root 2. Now, how do you know that is true? You can check by punching your calculator. I like to use decimals here. So I have square root of 3 plus 2 square root of 2. We have this. And our final answer again is 1 plus square root of 2. Same thing. So we are good. So that means the answer is okay. So that's what we have there. So then we go back to the notes now. So x equals 1, y equals 2, and we end up getting 1 plus root 2. Then we talk about symmetric surd expressions. So there are cases where you have symmetric surd expressions, expressions of the form root a, square root of a plus 2 root b plus square root of a minus 2 root b often simplify nicely because the radicals cancelled cancel when squared actually. So if you let x be square root of a plus 2 root b and y is square root of a minus 2 root b. So if you say if you want to now look for x plus y squared, if you square everything, so you're going to get x plus y squared as x squared plus y squared plus 2xy. X squared plus y squared is actually x squared plus y squared is you squaring a plus 2 roots b, and so you square this, you get a plus 2 root b. You square this, you get a minus 2 root b. And that's like 2a, because 2 root b and minus 2 root b will cancel out, and you get your 2a. And next, you can compute xy. So for xy now, that'll be square root of a plus 2 root b into a minus 2 root b. So if you simplify that, you have difference of two squares in there, and xy is square root of a squared minus 4b. So x plus y at the end of the day is now square root of 2a plus 2 root a squared minus 4b. That's what that simply represents. Okay. Yeah, I mean, all that story that has been told now, let me just go and do it on the worksheet so you can really get the gist. So root a plus 2 root b. So it's more like just want to square this whole thing. So root a plus 2 root b plus root a minus 2 root b. Okay. So you have root a plus 2 root b plus root a minus 2 root b. Okay, so we have this. So we want to simplify, right? So to simplify this, we have, so we can square. So when we square, we have, if you use our normal expressions, that a plus b all squared simply means you have a squared plus 2 power 2 times a. That's 2 times a times b plus b squared. Okay, so we have this. So if we use that idea here, so this is our a now, and this is our b. So we have square root of a plus 2 root b all squared plus 2 into square root of a plus 2 root b into square root of a minus 2 root b, then plus square root of a minus 2 root b all squared. Okay, that's the idea. So this is like a squared plus 2ab times b squared. So of course, square we cancel roots, square we cancel roots. So we have those parts sorted. So we have a plus 2 root b here plus, so for this now we have 2. Now square, we also remember, right, that root a, or say root x root y is equal to root xy for that center one. So in that case, we can then have 2 now, root a plus 2 root b into a minus 2 root b. Okay, so plus here now we have a minus 2 root b. Okay, so 2 root b here minus 2 root b here cancelled. So we can go on and have a plus a. So that is 2a plus 2 root a plus 2 root b into a minus 2 root b. Okay, so now this is looking like difference of two squares. It looks like that case where we have a plus b into a minus b, and that will be a squared minus b squared. That thing under the root looks like that. So with that in place now, we have 2a plus 2. So here now, that's a squared minus 2 root b all squared, like that. Okay, so we have 2a plus 2 root a squared. When you square this now, minus 2 squared is 4, then root b is b, basically. So that this is what we then have. So you have 2a plus 2 root a squared minus 4b. You can factorize if you like. So you have 2 into a plus root a squared minus 4b. So that can be nicely taken care of. So you have 2 into a plus root a minus 4b. So that's exactly what you have here. So at the end of the day now, so if you are looking for just x plus y, this is what we had before. So if you take the square root back, if you go back to the original thing you had, this is what we had initially. So this expression. So we can then conclude, you can then say, square root of, what's that now? Square root of a plus 2 root b, okay? A plus square root of a plus 2 root b plus square root of a minus 2 root b will simply be square root of, okay, if we don't even bother about this, square root of 2a plus 2 root a squared minus 4b. So we can break things down like that. So we move on with that, and we have the next expression. So you want to simplify square root of 5 plus 2 root 6 plus 5, square root of 5 minus 2 root 6. So from earlier, we know that square root of 5 plus 2 root 6 is equal to root 2 plus root 3. And then we have this whole thing becoming, so square root of 5 minus 2 root 6 will be root 3 minus root 2. So root 2 plus root 3 plus root 3 minus root 2. Root 2 and minus root 2 cancel. Root 3 plus root 3 will just give us 2 root 3 from what we did before. Not to worry, in case that looks like magic though. Don't worry, I'm going to solve some practice problems to actually buttress that fact. Many Olympiad radicals contain hidden perfect squares. So look for expressions of the form a plus b plus 2 roots ab, which equals root a plus root b, so you can actually simplify. So if you have to simplify square roots of 7 plus 4 root 3, so step 1, match with x plus y plus 2 root x, okay, so that you now have x plus y is 7, and in this case now 2 root xy is equal to 4 root 3. So divide through by 2, you have roots xy equals 2 root 3. When you square now, root xy will now be equal to root square of root xy is xy, and then square of 2 root 3, that will be 4 times 3, 12. So you need two numbers, add to get 7, multiply to get 12. Those are 3. That will be 3 and 4 easily. So in that case now, you just have square root of 7 plus 4 root 3 to be root 3 plus root 4, and root 4 is 2. So 2 plus root 3 in that case. So, and then we also have the idea of rationalizing sorts. Expressions containing radicals in the denominator can be simplified using conjugates. So example form, you have 1 over root a plus root b. So you multiply numerator and denominator by the conjugate, root a minus root b. So you have 1 over root a plus root b equals root a minus root b all over a minus b, because that will be difference of squares, right? Because this will be root a 1 times root a minus root b, that's a root a minus root b. Root a plus root b times root a minus root b, that will be a squared minus b squared. That will be root a squared plus root b squared. That's a minus b easily. So for example, 5, now we have that case. You have 1 over 5 root 5 plus root 3. So you have 1 over 5 root 5 plus root 3 times root 5 minus root 3 all over root 5 minus root 3. Because the idea is like you're multiplying this expression by 1, and multiplying something by 1 doesn't change anything, right? That's why after multiplying and doing and rationalizing, the expression you started with is still the same as the last one, except that now you have removed irrational numbers from the denominator, right? So here 1 times root 5 minus root 3 is root 5 minus root 3. Then root 5 plus root 3, root 5 minus root 3, that's a plus b into a minus b, that's a squared minus b squared, that's root 5 squared minus root 3 squared, that's 5 minus 3, and that's 2. So root 5 minus root 3, that's 2, like that. Okay, so Olympiad pattern recognition checklist now. When simplifying sorts, check for the following patterns: expressions of the sort, expression of the form a plus 2 root b, then possible representation as root x plus root x, root 2x plus root y all squared, then symmetric expressions such as root a plus 2 root b plus root a minus 2 root b, then use of conjugates for rationalization. So you want to check out all of that if you're dealing with Olympiad questions. So what I'm going to do here is to um, I mean, there's a lot. I'm tempted to do a whole lot here. Okay, I'm going to take two questions from each, from 1 to 10, two questions from each part, especially since this is the last video. So I'm going to take question. Let me take question. Uh, okay, I don't know. Okay, I'm going to take question 8, and yes, I'll take question 8 and question 10. Okay, I mean, for question 10, I think I can just go to question. So maybe I'll answer 3 now. Question 8, question 12, And okay, I mean, let me just take them as, let me just take one after the other. Once I take one, I'll come back and see another one I need to take. So question 8, we're looking for uh root 13 plus 4 root 12. Root 13 plus 4 root 12. Root 13. So just to simplify, root 13 plus 4 root 12. Okay, so we let root 13 plus 4 root 12 be equal to square root of x plus square root of y. And then we square both sides. Square both sides. So when we square both sides, square both sides. So when we square both sides, we have square root of 13 plus 4 root 12 equals, okay, we square that. Then we have root x plus root y all squared. So roots power cancels root. So we have 13 plus 4 root 12, and that is equal to x plus 2 root xy plus y. So that means 13 plus 4 root 12 is equal to x plus y for the rational part plus 2 root xy for the irrational part. So comparing terms now, comparing terms, we are comparing rational and irrational terms. So we have x plus y equals 13 here. So this is equal to this. And then the other part, 2 root xy is 4 root 12. Okay, 2 root xy, 2 root xy is equal to 4 root 12. So divide through by 2, we have root xy equals 2 root 12. Okay, so square both sides. So you have root xy all squared equals 2 root 12 all squared. So we have 2 cancels, power cancels roots. So we have xy equals 2 squared into 12, right? 2 raised by 2, then into 12. Root 12 squared is 12. So xy now is equal to 4 times 12, right? That's 48. Yeah, 48. So we have two things now. X plus y is 13. X plus y is 13. And xy is 48. So we need two numbers. Multiply to get 48. Add and you get 13. The factors of 48 are 6 and 8. All right, 6 and 8 is 48. 6 plus 8 is not 13. Oops. Okay. What about 12 and 48? I mean, if it is this difficult, it probably means there's nothing, we can't get whole number parts. So it means we're going to get something more complicated than what we started with. 48, right? 48 is 16. Is it negative where we started out with? It's positive, actually. So if it is negative, maybe that can work. Let me check again. Is it negative? 13 plus 4 root 12, it's not negative. So here it becomes like, so 48, let me just check. 24, 2, 12, 2, 6, 2, 3, 3, 1. Okay, that's 16 times 3, 48. We can also have 8 times 6. 8 times 6 is 40. 8 plus 6 is 14. What else? 16 and 3 is 19. Okay, I mean, it simply means that we are going to have more complicated solution than what we started with. So we cannot factor it directly like that. So we did, in the last video, I think I had a case like that. So it's okay. So I just move on to, I'm looking at, uh, we need to simplify or evaluate, right? Simplify or evaluate. Um, okay. Now, most of the questions are very tempting. Okay, so let me do 4 plus 2 root 3 plus 4 minus 2 root 3 to simplify. To simplify, To simplify, square root of 4 plus 2 root 3 plus square root of 4 minus 2 root 3. Okay. Yeah. Square root of 4 plus 2 root 3 plus square root of 4 minus 2 root 3. We want to simplify that. So to simplify this, right? So let, so we can let it be something, right? So we let A be equal to square root of 4 plus 2 root 3 plus square root of 4 minus 2 root 3. So A is what we are looking for in short. So A squared is equal to square root of 4 plus 2 root 3 plus square root of 4 minus 2 root 3. Okay? All squared now. So that A squared now is equal to, so we expand. So we have square root of 4 plus 2 root 3 all squared plus 2 into square root of 4 plus 2 root 3 into square root of 4 minus 2 root 3 plus square root of 4 minus 2 root 3 all squared, so that A squared now is equal to power 2 cancels root, power 2 cancels root. So here we have 4 plus 2 root 3 plus 2 now. So this one now, everything goes inside. So we're root 4 plus 2 root 3 into 4 minus 2 root 3. Then here we have 4 minus 2 root 3. So minus 2 root 3 cancels plus 2 root 3. So we have A squared to be equal to 4 plus 4. That's 8 now, plus 2 root 4 plus 2 root 3 into 4 minus 2 root 3. Okay, so that A squared now is equal to 8 plus 2. So inside here, we have difference, we have A plus B, A minus B. That's difference of 2 squares. That's like 4 squared minus 2 root 3 squared. Okay, so that A squared is equal to 8 plus 2 root 4 squared is 16. 2 root 3 squared is, that's 4 into 3. That's 2 squared. Let me do it this way. So that's 2 squared into 3, right? So that A squared now is equal to 8 plus 2 root 16 minus 2 squared is 4. 4 times 3 is 12. Okay, so A squared is equal to 8 plus 2 into 8 plus 2 into square root of 16 minus 12 is 4. Okay, 16 minus 12 is 4. So that A squared is equal to A plus 2. Root 4 is 2. So A squared is simply 8 plus 4, right? 8 plus 4, and then A squared is equal to 12. So finally, that A itself is square root of 12, and then that means that A is root 12. Root 12 is 4, root 4 times 3. So A is finally, root 4 is 2, and root 3 remains root 3. So we can conclude, so we can conclude finally, what do you study? 4 plus 2 root 3. So square root of 4 plus 2 root 3 plus square root of 4 minus 2 root 3 is simply the same thing as 2 root 3. Isn't that interesting? So of course you can check to be sure what you have done is correct, right? So let me go to decimals as usual and check. So you have square roots of 4 plus 2 square root of 3, okay, plus square root of 4 minus 2 square root of 3. That's that. And we ended up getting that to just be 2 square root of 3. Perfectly the same, right? So that goes. So that's what we have for that right there. Okay. So I think I want to take other questions. So we just did this now. Okay, to simplify this, you already know how to do this. Okay, let me take Okay, let me take 18, 19, and 20. I'm fired up to take all of this. 18, 19, 20. So let me go for 18. 18 is square root of 2 plus root 3 times square root of 2 minus root 3. Okay? Square roots of 2 plus, oh, I think I didn't get something quite right there. Square root of, oh, okay, that's fine. Square root of 2 plus root 3. All right. Square root of 2 plus root 3 plus multiplied, it's multiplication now, multiplied by square root of 2 minus root 3. Okay, like we know, this is just going to be equal to s- big square root of 2 plus root 3 into 2 minus root 3, basically. And then that is equal to square root of, so you can do difference of two squares, right? Because this is 2 plus root 3, 3 minus root 3. So you can recall, recall that a plus b into a minus b is equal to a squared minus b squared. So this is now square root of 2 squared minus root 3 squared. Okay, that's simply square root of 2 squared is 4, root 3 squared is 3. So that's square root of 1, and the answer is simply 1 right there. Okay, so we can check that to see if it is correct. So square root of 2 plus root 3 and multiply by square root of 2 minus root 3. Okay, square roots square root of 2 plus square root of 3 multiplied by square root of 2 minus square root of 3. It's simply 1. So that goes. All right. So like I said, I'm going to do all these ones. So the next one we have square root of 3 plus 2 root 2 plus 1 over square root of 3 plus 2 root 2. Okay. Um, so square root of 3 plus 2 root 2 plus 1 over square root of 3 plus 2 root 2. Let me confirm that to be sure. Okay, yeah, that works. Now let's go for it. So here now, I think the problematic part is this other second part. So we can leave this for now. So we have 3 plus 2 root 2, and we try to rationalize the other side. So we have 1 over 3 plus 1 over square root of 3 plus 2 root 2. So to take care of this now, we have to, this is a big sword now. So we first of all multiply by square root of 3 plus 2 root 2 up here, all over square root of 3 plus 2 root 2. Because this is more like, this cancels out, so it's 1. So it's more like if you multiply this by 1, nothing changes, okay? So if you multiply this part by 1, nothing has changed. So that's what's happening there. So this is this part now. We're working with this part. Okay, so nothing has been done to the first part, but we just keep carrying it along. So square root of 3 plus 2 root 2, okay, plus, so we rationalize, and that'll be up there we have square root of 3 plus 2 root 2, and down here, so it's like it's squared. So if we square it, we have 3 plus 2 root 2. Now, so that now changes the dynamic. So it's like this multiplied by this now. It is more like squaring it. So that changes the whole dynamics. And so the next thing is, what do we have to do? Um, we can still choose to rationalize. I'm trying to see. Okay, I'll keep going, right? Let's still try to rationalize, right? So we have, so or maybe we can even take LCM first. So anyone want, let's take the LCM. The LCM is 3 plus 2 root 2. Yeah, I think the LCM helps. So we have, it doesn't really help, does it? I think it doesn't really help. So maybe, let's finish rationalizing because the LCM doesn't simplify it. So again, we rationalize this part again because now the focus is on this root that is down here. So again, we have square root of 3 plus 2 root 2 plus square roots of 3 plus 2 root 2 all over 3 plus 2 root 2 multiplied by 3 minus 2 root 2 all over 3 minus 2 root 2. So now the question is about the conjugacy of this one. So that's why we have multiplied by, this cancels this. It's more like multiplying by 1. So, and the conjugate, what we get rid of this root 2 here is the conjugate of that expression. So we go again and we have this to be square root of 3 plus 2 root 2 plus, so this one now we have 3 minus 2 root 2 into square root of 3 plus 2 root 2 all over, okay, so this is 3 plus 2 root 2, 3 minus 2 root 2, that's like 3 squared minus 2 root 2 squared, right? So we have square root of 3 plus 2 root 2 plus, so this one now, we can leave it the way it is because it doesn't change anything yet. So we have 3 minus 2 root 2 into square root of 3 plus 2 root 2 all over. So now 3 squared is 9 minus 2 squared. 2 squared is 4. 4 times 2 is 8. Okay. So we then have, okay, I think it's looking prettier now. So this is square root of 3 plus 2 root 2 plus 3 minus 2 root 2 into root 3 plus 2 root 2 all over 1. 9 minus 8 is 1. So that makes life pretty easy. So in short, that means we have square root of 3 plus 2 root 2 plus 3 minus 2 root 2 into square root of 3 plus 2 root 2. So we have that straight up. So we can factor out this part and this part now. So we then have square root of 3 plus 2 root 2 on one hand into one of it here plus, when we take this away, we have 3 minus 2 root 2 here. So that'll be 1 plus 3 minus 2 root 2. So that this is now square root of 3 plus 2 root 2 into 1 plus 3. That's 4 minus 2 root 2. Okay, now are we satisfied at this point? Feels like we should keep going. I don't know. Maybe we should keep going. Yeah, I think it's better. Can we leave it this way? Now, these two parts can still be resolved, right? Okay, I mean, this particular part can still be done. So we have come to this point, right? So so let's give it a name so we can refer to it easily. So we can say let A be square root of 3 plus 2 root 2 into 4 minus 2 root 2. Because we can still simplify this, right? So we know that, so we say for root 3 plus 2 root 2. I think we've seen this before. Okay, let me just go straight. Let me not waste time. So let root 3 plus 2 root 2 be equal to root A plus root B. Okay, so we square both sides. I mean, we've done this a lot of times. So we square both sides. So we get 3 plus 2 root 2 equals A plus 2 roots AB plus okay, I mean this can, I shouldn't use A and B here again to avoid confusion since I already used A here. So let me say x plus y, root x plus root y. So x plus 2 roots xy plus y. Okay, so that is 3 plus 2 roots 2 equals x plus y plus 2 roots xy. So we comparing terms, we then have 3 plus 2 roots. Okay, first of all, we have 3, or better still, x plus y equals 3. So x plus y equals 3. Then secondly, we have 2xy equals 2 roots 2. So 2 roots xy rather, 2 roots xy equals 2 roots 2. So that means 2 cancels 2. So that means xy is also 2. Okay, so now, from all this, now we have x plus y equals 3 and xy equals 2. So if we deal with this whole thing, we just say that x is equal to 2 and y is equal to 1 because we need two numbers. When added, we get 3. When multiplied, we get 2. So 2 plus 1 is 3. 2 times 1 is 2. Okay, so we can then go back and say, so square root of 3 plus 2 root 2, which is equal to root x plus root y, okay, is equal to root 2 plus root 1. So that means that is equal to root 2 plus 1. And that's simply 1 plus root 2. So now that we have got that, we now take it back to where we are coming from. So we can simplify totally. So remember here now. So remember here. So we now say from A. So from A, which is equal to square root of 3 plus 2 root 2 into something, right? A is square root of 3 plus 2 root 2 into 4 minus 2 root 2. So A is square root of 3 plus 2 root 2 into 4 minus 2 root 2. So square root of 3 plus 2 root 2 now has been simplified to be this. So we now have A to be equal to, this whole expression now is 1 plus root 2. Okay, so it's looking cooler. So 4 minus 2 root 2. Nice. So we can then expand further. So A is equal to, so we can expand. So we have 1 into 4 minus 2 root 2 plus root 2 into 4 minus 2 root 2. Okay, so that means that A is equal to 4 minus 2 root 2. I mean, this is really feeling like an Olympiad question indeed. So 4 minus 2 root 2, 1 times 4, 4. 1 times 2 root 2 is 2 root 2. Root 2 times 4 is 4 root 2 now, minus root 2 times 2 root 2, that's 2 root 4. Okay, that's 2 root 4. So we have A equals 4 minus 2 root 2 plus 4 root 2 minus 2 times 2, okay, which is 4. So we have A equals 4 minus 2 root 2 plus 4 root 2 minus 4. So minus 4 plus 4 gets out. So A is equal to 4 root 2 minus 2 root 2. That's simply 2 root 2. So all the trouble all along has been to get 2 root 2. So A is 2 root 2. So in short, we are saying that square root of 3 plus 2 root 2 plus 1 over, so square root of 3 plus 2 root 2 plus 1 over square root of 3 plus 2 root 2 is simply 2 root 2. Can you imagine the trouble? So, okay, we want to check again. I always like to double check to be sure what we have done is correct. So, let's do that. So we have square roots of 3 plus 2 square roots of 2, all right, plus 1 all over square roots of 3 plus 2 square roots of 2. So it gives us that. And what's the final answer we got? 2 square root of 2. Exactly the same thing. So we are good to go. So that's fine. So like I promised, I also want to solve the last one. 5 plus 2 root 6. So you keep solving until, so what I've seen here is, I was tempted to stop somewhere, but you keep solving until you have something as simplified as possible. Okay, so for this other one now, the last one, we have 5 plus 2 root 6 minus 5 minus 2 root 6 all squared. Okay, 5 plus 2 root 6 minus 5 minus 2 root 6 all squared. No, I think I'm getting it wrong. I think it's square root of 5 plus 2 root 6 minus square root of 5 minus 2 root 6 all squared. I think that is what it is. Okay, square root of 5 plus 2 root 6 minus square root of 5 minus 2 root 6 all squared. Yeah, so now that's it. So here we have, so we are squaring. So again, we use the idea that, so we recall, or let me do it by the side so I don't have to waste time. So recall that A plus A minus B all squared is equal to a squared minus 2ab plus b squared. That is a raised to power 2 minus 2 times a times b plus b squared. So with that idea now, we now come for this, that this is equal to, so first of all, 5 plus 2 root 6 all squared minus 2 into 5 plus 2 root 6, all right, into 5 minus 2 root 6, then plus root 5 minus 2 root 6 all squared, okay? So that's equal to, of course, the root cancels power. So 5 plus 2 root 6 on this side minus 2 root 5 plus 2 roots. Okay, well, I can even take care of that. This is difference of 2 squared straight. So that's 5 squared minus 2 root 6 squared straight up plus 5 minus 2 root 6. So minus 2 root 6 cancels 2 root 6. So that is equal to 5 plus 5 is 10 minus 2 root 5 squared is 25 minus 2 squared is 4. 4 times 6 is 24. Interesting. So this is now 10 minus 2 root 1. So that is 10 minus 2 because square root of 1 is 1. So that is 8 in short. So what all that is just 8. So, oh, if I can change. So, what's that now? 5 square root of 5 plus 2 root 6. So square root of 5 plus 2 root 6 minus square root of 5 minus 2 root 6 all squared is equal to 8, basically. Okay? So let me check that that is correct. So we have square root of 5 plus 2 square root of 6 minus square root of 5 minus 2 minus 2 square root of 6 raised to power 2. That's 8, okay? And that's what we got. So that's 8. That's 8. So yeah, so that's it right there. So with this, we come to the end of this interesting video again on Olympic level sword manipulations. So I mean, it's simple, but you have to understand the patterns. You have to recognize the necessary patterns and everything. So don't forget to try your hands on the questions. I've tried more than, I think, about 4 of these questions. So try your hands on 1 to 10, try your hands on 11 to 20 to be sure you really understand the gist. So with this, I come to the end of this video and the end of this playlist, except something else comes up. This is the end of Surds. Let me know how helpful this is for you. And if there's something else you'd like me to try out, feel very free to let me know. If you have subscribed to this channel, I thank you very much for doing that. And if you haven't subscribed, question, what are you waiting for? Go ahead, subscribe, hit the notification bell so you can always get alerted each time a new video is released. Having done that, you can also become a member of the channel by clicking on join. That gives you special privileges like like seeing some videos before others see them, or being the only one to see certain videos because you are members of the channel. You can also request for PDF copies of my notes as a member of the channel, and we can hang out together to discuss whatever interests you on this channel, whether it is mathematics or data analysis or data science, machine learning, scholarships, writing books, whatever interests you on the channel at all. You can look at that. So ultimately, don't forget to comment, like, share, so that more people can have access to the great content I have going on here. Till I come your way again, keep doing maths right. Bye.